Hello everyone, it's Mr. Wolf here, and in this video I'm going to be discussing round 2, scenario 3 for video modeling. Alright, so this is the scenario where we're going to have a negatively charged PVC pipe come close to a neutral can. They're not going to touch, they're just going to come close, and the question is, what is going to happen between those? Is the can going to, are they going to be attracted? Are they going to repel? Is nothing going to happen? Or are they going to explode? So, let's first start talking about our two objects. So we have a PVC pipe. It's an insulator, it's plastic. And which means that electrons cannot move freely throughout my object. And we could already start to see this with how I've kind of modeled these electrons clumped up right here. Now something I haven't done yet, and this object has a charge of -4. Since it's negatively charged, it has more electrons compared to protons, which means, and if it has a charge of -4, that I need to add 4 extra electrons to my insulator. All right. So negatively charged. Then I have my can. It is a conductor, which means electrons can move freely through the can. And right now my can is neutral, which means it has an equal amount of protons to electrons. So 10 protons, 10 electrons, 14 electrons, 10 protons here. All right. So now we're going to bring the PVC pipe close to the can. In this case, we can imagine that beforehand they were far away from each other. Now we're going to bring them close together. Right. Remember that since I have an insulator here, it's positively charged. Specifically, it's really charged positively on this part of the insulator right there, where my charge is localized. And I want to ask the question, well, okay, they're not touching, but still, which way do electrons want to go? And the electrons in my can are repelled away from all these excess electrons that I have here. And I just realized that I made this positive. Sorry, negative. All right, so the electrons here are repelled from all these excess electrons in my insulator. Right? So then the question is, well, okay, they want to move away, but can they? And yes, this is a conductor, which means that these electrons can get as far away from the electrons, excess electrons, in my insulator as possible. So all of a sudden that these atoms become positive. They're missing some electrons. Right. These atoms become negative. They've gained some extra electrons. Right. And there's still some atoms in my material that are still going to be neutral. Right. Now that electrons have shifted over, first of all, the overall charge of my object would still be neutral, right? I haven't gained any electrons. I haven't added any electrons, so there are still 10 electrons, still 10 protons, right? But obviously something has happened. Electrons have shifted over. So since electrons shifted over here, this side of my can is going to be negative. And since electrons left this side of my can is going to be positive. Right? So then the question is, what's going to happen when we bring the PVC pipe close to the can? Right? If this side of my can is positive and my PVC pipe is negative, opposites attract. So my can is going to be attracted to my PVC pipe without them even needing to touch, without even electrons needing to move from one object to another, just moving within the object to make one area of that object more positive or more negative.